Welcome. We're starting Unit 7, and we're going to start with Lesson 1 on probability. Our class expectations are to stay on task, chat and work only about the topic, be fully engaged, answer questions, participate in discussions, use your calculator and Desmos, practice using that will help you immensely when it comes to test time. Go to the board when asked. If you need help, your teacher will always help you. Your classmates will help you. It's hard being at the board, I understand, and we don't always have the answers. But going to the board will help you get more confident working together with your class members. Everybody helps students at the board. Remember to ask and answer questions and be positive and polite. Our learning targets: conducting experiments with probability, identifying distribution, using probability notation efficiently, so pay attention to how we're using notation today, making predictions based on theoretical probability, and comparing that theoretical probability to our experimental probability. The first thing we're going to do, take about 5 minutes to work with your shoulder partner to answer the following questions. If your partner is absent, work with someone else who does not have a partner, or ask another group of 2 if you can work with them. Discuss your answers. Write down your final answers in complete sentences and be ready to share out. So use those 5 minutes productively. We're looking at this container at the top where we have dropped in some balls. It's a funnel shape where we have an unlimited, infinite amount of balls that we're dropping right in the center of this device that's like a Plinko device, if you've ever seen that game. And then it's going to fall through and drop into these containers below. Okay, and I want you to talk with your group and answer question 1. How would the balls flow from top to bottom? So we have 3 illustrations here. This first one is uniform. The second one is bell-shaped, because it makes kind of a bell shape, higher in the very center and then tapering off on the ends. And then the last one is random. Okay, so do you think it would be uniform, random, or bell-shaped? Okay, so answer in complete sentences. Discuss with your group. You don't have to agree, but write down your final answers in complete sentences and be ready to share out your answers and your logic. You can pause the video here to think about that, and then we'll move forward. Today we're going to be talking about sample spaces, events, outcomes, and we're going to be conducting experiments like we did before spring break. All right, so now let's experiment and compare the outcomes. So go to Google Classroom. In our classroom, at the very bottom, you'll find class materials. Open up the Galton board. Conduct an experiment, making the adjustments that you see to the right. All right, so when you open up the Galton board, you should see this. So we're going to change our size to 9 because we have 9 containers. With those balls being dropped, they can fall into 9 different containers. And then we're going to change, if it's not already, 50-50, okay, and make that adjustment left to right to 50-50, and then speed it up as fast as you can. So you can see in this illustration that I have to the right, I've dropped 14 balls already, and then you don't see the bottom, you don't see the shape. But we're going to drop at least 500 times. That's why we want to speed it up. And you can go over 500. We just want to do it at least 500 times. And then after you've done it, this experiment where you've dropped at least 500 of the balls, then look again and see if you need to revise your answers. So pause the video here if you're watching from home. Do this and revise your answers. We're going to start by defining probability. Probability is the branch of mathematics that concerns numerical descriptions of how likely an event is to occur, or how likely it is that a proposition is true. We're often given propositions and people try to confuse us and confound us because we don't have access to the data with propositions trying to prove that it's true. If we look deeper often or think about it a little bit more, then we can make better judgments for ourselves than just relying on people to tell us what's true or untrue. All right, so let's look at a Let's look at a scale from 0 to 1 because probability is a number from 0 to 1. Okay, we did a coin toss, simulation of a coin toss, where you have heads and you have tails. So the probability of landing on a heads or tail is 50-50 or 1/2, 50% or 1/2. Okay, and then I've divided this up into 4 sections. So this unlikely would be 1/4. Anything below 1/2 is unlikely. Highly unlikely would be closer to 0. And then likely would be 3/4. Closer you get to 1, it becomes more highly likely. Just remember that probability is between 0 and 1. All right, other definitions. An experiment is a process that has a number of distinct possible outcomes in which the result cannot be predicted with certainty, because with an experiment, there are a lot of factors that can vary the outcome. The outcome is any possible result of the experiment. The sample space is the set of all possible outcomes of the experiment. And let's go back to the coin tossing and let's try. When you toss a coin, we want to list the elements or the results when we toss a coin. So we have 2 sides to the coin if it's a fair coin. So we're always looking for, analyze what we're experimenting with, make sure that it's a fair experiment, there's no bias. So it should have 2 sides, heads and tails, and it's not weighted. We have heads and we have tails. So on the first toss, it's 50-50 or 1/2 probability that I'll get a heads, 1/2 probability that I'll get a tails, and our outcomes should always add up to 1, our possible outcomes. Rolling a die. All right, how many sides of the die do you have? Think about that. We have 1, 2, 3, 4, 5, and 6. So if I ask for the probability of rolling a 2, that probability is going to be what I'm looking for. The outcome I'm looking for is a 2, and there's only one of those out of the total possible outcomes, and there are 6 of those. 1, 2, 3, 4, 5, 6. So that probability is 1 out of 6. All right, now what I want you to do is, if you're in class, we're going to ask the birth month of everyone in the class. So take a piece of paper, number it, put down the person's name, and then ask them what month they were born in, and then organize your data on a table. All right, let's look at some other examples of experiments. Okay, we're going to list all the possible outcomes for the experiment of tossing 2 coins. Now I'm looking at a peso, so I've got a 5 peso coin and a 10 peso coin. So let me just put those up at the top so we'll have some workspace at the bottom. Now both of those have a head and a tail, so those are even and fair. They're not weighted. We're going to use a tree diagram to organize our data. We're going to start off with the first coin, and if we start here and we toss, it can go in 2 directions. It can go in the directions of heads. It can go in the direction of tails. Okay, 50-50 chance to go heads or tails. Then after the first toss, if I get a head and toss again on that second toss, it can go in the same 2 directions, heads or tails. But if I toss on the first toss and I get a tail, it can also go off in the same 2 directions, heads or tails. Now I'm going to follow that branch and list my possible outcomes. So it can be heads and heads. I can go heads and tails, I can also have the outcome of tails and heads, or tails and tails. So now with my tree diagram, these are my possible outcomes. All right, so practice drawing that tree diagram in your notes as a way to organize data from your experiment. We have to organize it. We can't keep it in our heads. Now, another way to organize your data is with a table. So we can put the first coin either across the top or the bottom. It's like making a multiplication chart or a rectangle to multiply polynomials. Now this first coin can go across the top or the bottom. I put it top or the side. I put it along the side. We have two outcomes, heads and tails. And then for the second coin, we also have heads or tails. So you're going to go down and across, just like with multiplying polynomials. So we're going to take heads and multiply it to heads to get heads, heads. Heads with tails to get heads, tails. Now we're going to go to the second row, multiply tails, first column, with heads to get tails, heads. And then the second row, tails with tails to get tails, tails. So those are the same four outcomes, heads, 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 tails, tails, heads, tails, tails. So look at that and decide how you would like to do that. On your test, I may be asking you to use a tree diagram. That's most often how we do it, but also know how to use a table to organize your data. Then list your possibilities. So we can see the probabilities of getting two heads. So two H's, we have 1 out of 4 possibilities, or 1/4. To get a heads and a tails, we have heads, tails here, or tails, heads here. Okay, in any order. So that's going to be 2 out of 4 possible outcomes, which reduces to 1/2. All right, and the last one is at least one tail. So we've got that here, at least one tail. So I've got one T here, one tail here, one tail here, one tail here. The only one that doesn't have one tail is the heads, heads. So that's 3 out of 4. Okay, our desired outcome is at the top. Our total possible outcomes is at the bottom. All right, let's look at some examples. We want to list all the sample space where a pair of dice are tossed. All right, now this time I made a table just to show you how we can organize. All right, I can toss on that first column. These are all ones. That first dice is a 1. In that second column, the first dice is a 2. And then 3, I'm looking at the red die, and then a 4, and then a 5, and then a 6, because the die has 6 sides. Now on that first column right here, I'm going to list all the possible outcomes in that second die roll. So we have a 1, a 2, a 3, a 4, a 5, and a 6. All right, so I'm listing the first row, and I have 6 columns, and then pairing that up with the second row, which we also have 6 outcomes. So now I can see it listed in table form. You could also do it in tree form. Let's look at an example where we're choosing an outfit to wear. So suppose you have to choose what outfit to wear. How many options do you have? If I have in my closet a red shirt, a green shirt, a yellow shirt, 1 pair of jeans, 1 pair of shorts, and a pair of Nike tennis shoes. All right, think about that for a minute. How many choices or options would I have to put these together? So this is the basic counting principle. We have 3 choices in shirts, red, green, yellow. 2 choices in bottoms, jeans or shorts, and 1 choice in shoes. Okay, so I have 3 here, 2 here, and 1 here. Okay, we take our outcomes, we multiply them together. So I should end up with 3 times 2 times 1, or 6. And I do. So here are your possible outcomes if you're putting together outfits to wear. All right, the fundamental counting principles. If one thing can occur in M ways, and a second thing can occur in N ways, and a third thing can occur in P ways, and so on, then the sequence of events that may occur is M times N times P. So you multiply your possible outcomes together to get your total possible combinations. That's the fundamental counting principle. All right, let's look at another example. A cafe serves 2 main courses, burger and steak, and 2 sweets, ice cream and cake. How many different variations and meals can a customer have? So for the main course, we have 2. And for the desserts or the sweets, we have 2. So we're going to take 2 times 2, and we should have 4 possible combinations or outcomes. And we do. We put this in this chart here. So there are 4 choices with those combinations. Let's look at this example. Double O's Cafe serves 3 desserts. So let's highlight that in our word problems. Let's get used to highlighting the important information. 3 desserts. We have a cake, a salad, and a pie. And we have 4 beverages, cola, coffee, tea, and juice. Suppose you choose 1 dessert and 1 beverage. All right, how many possible outcomes are there? So in the dessert category, we have 3 choices. And then in the beverage category, we have 4 different choices. So 3 times 4 would be 12. All right, we've gone over several experiments and we've talked about the definitions of probability. Remember that probability is a number between 0 and 1. And we've looked at several experiments, again, rolling die, tossing coins, cards, spinners. We can either spin by spaces, by colors, by numbers, different ways we can spin. So we need to really look closely at what it is that we're doing. All right, in the spinner, I can spin for a number. I have even probability of spinning a 1, 2, 3, 4, 5, 6, 7, or 8. But I have different probabilities of spinning colors, like yellow, that's 2 out of 8 or 1/4. Purple, that's 2 out of 8 or 1/4. Red, that would only be 1 out of 8. And then blue would be 3 out of 8. So the higher probability is the blue. Looking at the numbers, it's going to be even probabilities. Picking cards, you can choose by suit. You can choose by the value of the card. Ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King, so forth. So different ways to look at probability. Let's focus on the definition. Probability is the probability of an event. We denote it with P. Capital P means probability of E. E is the event. So the probability of an event occurring is the likelihood of that event. And we write it as P of E equals the number of ways that it can happen over the number of possible outcomes. So thinking about the spinner, we might look at the number of possible colors. So we count those. Those are the possible ways it can happen over the number of possible outcomes, the number of spaces. All right, let's look at problem number 1 on your worksheet. Let's work through this together. It says a die is rolled. What is the probability that the number is an odd number or a 4? Now I want you to notice something. I have the probability, using probability notation, of odd, and then this is or. It looks like a U, okay? We're going to unite that with the probability of the number 4. Or means either of these is acceptable. So let's count how many odd, let's count how many 4, and let's put those together and see how we can solve that. So I'm looking at my sample space. We can have a 1, 2, 3, 4, 5, or 6. Okay, and look at the odd numbers. There are 1, 2, 3 of them. And then the number 4, there's only 1. To work this problem out, you have 3 out of 6 that are odd. We're going to add that when we say or use this symbol. Looks like a U. And then add that to the number of possibilities of rolling a 4. There's 1 out of 6. 3 out of 6 plus 1 out of 6 equals 4 out of 6. You can reduce that to 2 over 3. So the answer, when we say, again, pay attention, when we say an odd number or, look at the symbol, looks like a U, we're going to add those two probabilities together. Question number 2. We have a set of cards numbered 1, 2, 3, 4, 5, 6, 7, 8, all the way through 16. So we need to read the question carefully, otherwise we'll think of a deck of playing cards, and that's not what we have here. We have just a set of cards, and I'm going to go ahead and put that sample space out so you can see it, numbered 1 through 16. Okay, so now we're looking for a card that's a multiple of 5 or a multiple of 6, and we're looking at or. Or always means add, okay, and we use this symbol that looks like a U, it means united. Okay, so we have 3 numbers that are multiples of 5, 5, 10, and 15, and then 2 numbers that are multiples of 6. 6 times 1 is 6, and 6 times 2 is 12. So 3 plus 2 over 16, that's going to be 5 over 16. Now we want the probability of a number less than 7 or greater than 8. Or always means the U, and it always means to add. So this is the symbol, this is the notation that I'm using for probability. The numbers that are less than 7, let's count those, are 1, 2, 3, 4, 5, and 6. So we have 6 of those. And greater than 8, we have 9, that's 1, 10, that's 2, 11, that's 3, 4, 5, 6, 7, 8. All right, so 6 plus 8, count those yourself, over the total possibilities of 16 is going to be 14 over 16. Those are both divisible by 2, and we get 7 over 8. Question number 3, we have a card selected at random from a pack of 52 playing cards. So let's put that sample set out there before we start trying to analyze this. And we're going to be looking at the probability of a heart or a black card. Or means we're uniting those two things together, so we're going to be adding this probability to this probability. So let's count our hearts. Our hearts are a complete suit, and we have 13 cards in each suit. And then our black cards, we have clubs and diamonds. So let's look carefully and make sure there's no overlap. If there's an overlap, we have to take cards out, but there's no overlap. Okay, now we're going to take 13. There are 13 hearts, and then black cards, there are 26. Add 13 plus 26 together and get 39 over 52. Now, in reducing that, look carefully. 13 goes into 39 and 13 goes into 52, and we reduce that to 3/4. All right, part B, we want an ace or a picture card. Picture cards are Jack, Queen, and king. All right, let me get a different color or erase that. Let me just erase it. All right, our aces, we've got 1, 2, 3, and 4. And then our picture cards, we have 12. We have 4 different suits, 3 picture cards in each, or 3 times 4 is 12. So adding those up, we get 12 plus 4, 16 over 52. And then we can simplify that by dividing 16 by 4 and 52 by 4 to get 4 over 13. Question number 4, we have a card selected at random from a pack of 52 playing cards. So it's the same sample set. I'll put that down below. And then we're going to start with the probability of a diamond or a red card. Okay, so let's count our diamonds first. We have 13 of those. I'm highlighting those 13 cards. Okay, and then the red cards, I'm going to choose a different color to highlight with because I'm going to show you that we do have an overlap. Okay, I'm going to choose green. Okay, our red cards are here. We've already counted those 13. So we're going to be adding those 13 back in. We're going to have to remember to take those out again. All right, so the probability of a diamond united with a red card, so we're going to be adding those together. And then we're going to take out, so this flips upside down. This U means or, this upside down U means and. So we're going to take that out. Okay, so 13 plus 26 minus 13 is 26 over 52. And then reduce that to 1/2. And you can look at your sample space and you can see that that's 1/2 of the cards. Okay, let's go to part B. We want a queen or a black card. So we're going to count our queens. Let me erase what I've highlighted so we can see it clearly. And then we'll start over again by highlighting. All right, our queens are here. So there's 4 of those. And our black cards, we've got 13 on the bottom and 13 on the top. And you can see where I have an overlap of 2 cards right here and right here. So we're going to have to take those 2 out. So 4 plus 26 minus 2 over 52 total cards is 28 over 52. That reduces to 7 over 13. Now we're going to look at tossing 2 coins. We're going to draw a tree diagram, which we've already done. So you should have this in your notes and all those possibilities. Okay, so we can just look for the 2 heads. There's only 1 out of 4 possibilities. And then a head and a tail. So there's 2 of those. Because we can start with the head, end with the tail, or start with the tail, end with the head. So 1/4 plus 1/4, that's 1/2. All right, lesson debrief. The probability is a measure of the likelihood of an event occurring. So we look at that event, and the probability values range from 0 to 1. 0 is not going to happen at all, and 1 is it's certainly going to happen. 0 is impossible, 1 is certain. The sum of all the probabilities in an event total to 1. The basic probability formula is P of A, where P of A is the probability of event A, is N of A, the number of favorable outcomes, and N of S is the number of total possible outcomes. Okay, and then we put a little table up here starting from 0 to 1, where 0 is impossible. Make sure that you understand these words match. 0 is impossible. 1/4, if you see 1/4, it's unlikely. Doesn't mean it can't happen, but it's unlikely. Okay, right in the middle is an equal chance. It's 50-50. 3/4 is likely. That's more likely. And the closer you get to 1, it's even more likely, but 1 is certain. The sample space is a set of all possible outcomes of an experiment. An event is a subset of the sample space, so the event is what we're looking for to happen to see what that probability is. For example, when you're rolling a die, the sample space is 1, 2, 3, 4, 5, and 6. Notice that those are enclosed in curly brackets. But when we look at the subset, we're looking at the event. For example, rolling a 2 or a 3, we would have 2 out of 6. Another event could be rolling an even number, which would be 2, 4, or 6, which are 3 of those numbers out of 6, or 1/2. A tree diagram, we can use that to show the number of possible outcomes in an experiment. Now we've looked at tossing a coin, but we can look at rolling die and write that also as a tree diagram. Let me go back. And then uniform distribution. Look at that graph. Make sure that that soaks in. Uniform distribution is where everything is just, however you're drawing this space, is distributed evenly. The frequency of each variable is evenly spread out across the values. Now we're going to look at random distribution and look at how that's different. It's just going to end up, we can't predict how that's going to end up. It's totally random and it's determined by chance. And then the bell-shaped curve, let's look at that. It's higher in the center and then it tapers off on the ends or the tails to the left or to the right. All right, complete the remaining problems on your worksheet. Study the Quizlet study set to prepare for a quiz on Wednesday. How do you feel about today's lesson? If you still need help, if you're here, if you initial this on the board, you still need help, come to office hours on Tuesday from 3 to 4. If you're going to independently keep studying, let me know if there's anything I can support you with there. And then if you're here, good for you. But every time that we present a new lesson, don't expect to get it right away and make sure that you ask for help if you need it. Thanks for coming.